I want to talk to you a little bit about errors and power. We don't get into a lot of this in this class. We will not learn how to calculate power, but you need to sort of understand the relationship between errors and power and what our errors are. So of course, even with all of the evidence in the world, we're still going to make mistakes or make the wrong decision. Sometimes we should reject the null and we don't. Sometimes we don't and we should. So there are special names for each of those. A type 1 error occurs when the null hypothesis is true, but we mistakenly reject it. So the null hypothesis is true, but we mistakenly reject it. That's a type 1 error, which essentially is a false positive. So in this case, our patient is not pregnant is the null, and the alternative is that it is. So here, notice this man is being told that he's pregnant, which of course is not true. But essentially we're saying that that's a false positive. The null hypothesis was true, the patient is not pregnant, but we mistakenly reject it to say that the alternative is true. Here, the type 2 error is a false negative. So that's saying the null hypothesis is false, the null being the patient is not pregnant. Obviously that's very false in this case. And we fail to reject it. So we've made an error and failed to reject it, which is a type 2 error. Whichever error is more serious depends on the context of the situation. So basically it's context dependent. So over here we can see all of the possibilities. So this is the truth. Either the null hypothesis is true or the null hypothesis is false. If it's false and we reject it, that's a good thing. If it's true and we fail to reject or we retain it, that's a good thing too. So we made the right decision. A type 1 error occurs when the null is true, but we reject it. So we reject the null hypothesis, but we should have failed to reject. That's type 1, and same for type 2. So a type 1 error will occur when rejecting a true null hypothesis. And that, I don't know why it's showing up as a check mark. This should be our alpha level. So since a type 1 error is rejecting a true null hypothesis, the probability of a type 1 error is our alpha level. So type 1 equals alpha level. So whatever's on the outside, remember that's what we're testing it against. When it's false and we reject it, we've done the right thing. This is called the power of the test. So again, we're not going to talk a lot about power, but what you need to understand about power, in case they ask, is it's really just the test ability to detect a false hypothesis. Okay, so basically saying the null hypothesis was false and we rejected it, which was a good thing. That's the power of the test. Now, when our null hypothesis is actually false, but we fail to reject it or we retain it, that is what's called a type 2 error. And we use beta as the symbol to assign, basically to say that that's the probability of a type 2 error. And again, we're not going to get into the calculations of how to compute that. It's harder to assess the value because again, it's based on the parameter, which we don't always know. So just know that that's the letter that we use, beta here and alpha here. So one way to focus our attention on a particular beta, I don't know why bicycle is showing up under there, but it's beta, to think about the effect size. So how big of a difference would matter? We could reduce beta for all of the values by increasing alpha. So as alpha increases, beta decreases, and vice versa. So of course that would make our type 1 error increase as well. So you're always going to have a chance for error. If you increase the value or decrease the chances of making a type 1 error, you're increasing type 2 and vice versa. And the power of a test is the probability that I correctly reject the false null. The power is 1 minus beta. So here's sort of a visual way to see what's going on. Suppose the null hypothesis is true. This is all good stuff. Okay, this is alpha, which is of course my type 1 error. This is beta, which is my type 2 error. This is my power, which is, suppose the null hypothesis is not true, so here is where I am rejecting the null. So this is failing to reject, and this is rejecting. So hopefully that kind of makes sense. So if I moved the bar this direction, beta would decrease, alpha would increase, etc. So we get the basic idea there. The main thing I want you to understand, other than the sort of tension between alpha and beta, and as one is increasing, the other is decreasing, is that the only way to make both types of error decrease is to increase the sample size, because increasing the sample size changes the curve and changes how much area are in those tails. So increasing sample sizes decreases both types of errors. So I really just want you to understand some of the basics of error and power. And so here is a really good question to sort of test your knowledge to see if you actually understand what it's all about. So if you would press pause and try these questions, and then press play to check your work. So here we have 2003, 68.3% of American families, 68.3% of American families owned their homes, and in Bennington, which is a small town near Omaha, data revealed that ownership rate was much lower, so lower being important here. They decided to offer tax breaks for a 2-year period to try to increase home buying rates. So they're trying to increase the rates. Is there a significant increase? If there is, they're going to keep the program running even though the city is losing tax money. So of course, the first thing we have to do is the null and alternative. Remember that the null is always that nothing has changed. So the null is going to be that the proportion is equal to 0.683. Notice this is still a proportion question rather than a mean, but it doesn't matter. It's the same thing. So in Bennington, they're saying that it's lower, but remember what they're trying to decide is if they offer tax breaks, will it increase? So here, this lower is here to throw you off. So my alternative hypothesis should be that it's increasing because the home ownership rate would be greater than what it was previously. Again, because they're trying to increase home buying rates using the tax break. So what would a type 1 error be? Remember, a type 1 error is when the null is true. So this is actually true, but we reject it in favor of the alternative. So in this case, we'd say that the proportion of homeowners is actually 68.3, but we believe that the alternative is true, so we believe that the home ownership rate has increased. The type 2 error is that the null is false, but we say it's true, which means we said, oh, it's greater than 68.3 when it actually was 68.3. So the null is false, but we claim that it's true. And the proportion of homeowners is greater than 68.3, that's the alternative, but we believe it is 68.3, which is our null. Now here's the most important part. So who is going to be harmed? Well, if the null is true, if the proportion of homeowners is 68.3, but we believe that it's higher than that, that means we thought that these tax breaks worked, right? So we're going to keep offering these tax breaks, which means the city is going to lose money based on those tax breaks, even though they're not making any difference. Type 2, saying that the proportion of homeowners is greater, but we don't think it's changed, means we're going to stop this benefit to these homeowners because it actually was helping to increase the home ownership rate. But we said, hey, it's not working, so we're going to stop the program. So the home buyers will lose those benefits. And then, of course, if they ask about power, it's always the exact same sentence, the ability to correctly reject the null. In this case, the null is P equals 0.683.